In this video lesson, we will learn about different types of triangles and also how to identify them. So first, the type of triangle depends on the type of angles that it has. So there's three types of angles that we care about. And those are acute, right, and obtuse. So a right angle is an angle of exactly 90 degrees, which we label with the little box that I drew. So exactly 90 degrees. Now acute angles. An acute angle is any angle less than a 90 degree angle, or smaller. So anything that's sort of folded in more. You can imagine taking the right angle and then folding in the legs closer together, the line segments. So it's angles between 0 degrees and 90 degrees, not including 90. Because once you reach 90 degrees, you're already a right angle. So now obtuse angles. That's the opposite of an acute angle. It's more than a right angle. So you can imagine unfolding a right angle, taking it and opening it further. So for our purposes, obtuse angles are angles between 90 and 180 degrees, not including the endpoints. So 90 degrees is not an obtuse angle, and neither is 180. Alright, so now we got the types of angles down. Let's talk about the types of triangles. So an acute triangle is a triangle which only has acute angles. So all three angles in the triangle are between 0 and 90 degrees, not including 90. A right triangle has exactly one right angle. An obtuse triangle has exactly one obtuse angle. It's actually impossible for it to have more than one right angle or more than one obtuse angle. If you want to know why, then you can look at my video lesson, the sums of the angle of a triangle, angles of a triangle is 180 degrees. But anyway, now let's talk about what types of triangles these are. This first one is obtuse because the angle I highlighted is more than 90 degrees. This is what 90 degrees would look like, and that's obviously a little bit more. So we have an obtuse triangle here. Next, I'm looking at all three angles here, and all three are small angles. Angles smaller than 90, so acute. Since they're acute angles, and here I'm just drawing what 90 degrees would have looked like. So you can see that the angles we have are actually smaller. So they're all acute, so the triangle is an acute triangle. So I label it an acute triangle. And now the last example, this is a 90 degree angle that we can see. It's a right angle, and since there's a right angle, it's a right triangle. And that's all there is to it. Alright, well, that was easy, but you're not always so lucky to have a drawing. So what happens if you don't have a drawing and you can't see the angle? If you're just told the angles, or you have a drawing to look at, you can just tell some angles are small, some angles are large, some are acute, some are obtuse, and everything is simple. But now we have the following problem. What if you just get side lengths? So for example, let's say I give you a triangle and I don't draw it for you, I just tell you that it's got side lengths 3, 4, and 5. Well, we're going to do a few examples, and I'll teach you along the way how to do this. You have to follow the following recipe. You start with the largest number of the three sides, the largest length, and in this case, the first one, it's 6. And you compare 6 squared and the sum of the squares of the other two sides, in this case 3 and 5. So I have 6 squared compared to 3 squared plus 5 squared. So 6 squared is 36, 3 squared and 5 squared, that's 9 plus 25 is 34. So I get 36 compared to 34, and 36 is of course larger. So if the square of the largest side is larger than the sum of the squares of the two smaller sides, then we have an obtuse triangle. So remember, square of the largest side is greater, it means obtuse. No, we never even had to draw this triangle or do any sort of looking. We just plugged it into this formula and it worked. So now we're going to look at the next triangle in the example. So it's 5, 5, and 8. 8 is the largest side, so we're comparing 8 squared, and the other two sides are 5 squared plus 5 squared. So 8 squared is 64, we know that. And 5 squared plus 5 squared is just 25 plus 25, or 50. So the square of the largest side is greater, just like before. So once again, we have an obtuse triangle. Alright, let's try out the next example. So we have 6, 4, and 5 are the side lengths. 6 is the largest side, so we're comparing 6 squared to 4 squared plus 5 squared. Now I calculate, 6 squared is 36, 4 squared plus 5 squared is 16, plus 25 is 41. 36 compared to 41, 36 is smaller. So in this case we have something new. The square of the largest side is smaller, and this means that the triangle is acute. Great. So now we have the final example. And we're going to apply the same principle. We pick the largest side, and that's 10. 10 squared is 100. And then we have that compared to 6 squared plus 8 squared. So we calculate. 10 squared is, like I said, 100. 6 squared plus 8 squared is 36 plus 64. And I add these and I get 100. So we have 100 and 100, so they're equal. And in the case that we have equality, that is a right angle. So that gives us all the answers. So remember, if the square of the largest side is greater than the sum of the squares of the other two sides, if it's greater, then we have an obtuse angle. If it's less, we have an acute angle. If it's equal, we have a right angle. Well, I hope that helped, and thank you for watching this video lesson.